Hey, Doc, we better back up. We don't have enough road to get up to 88.
Roads? Well, we're going, we don't need roads.
Ah, what a classic line from Back to the Future. It's all about venturing into unknown territories. And speaking of unknown territories, welcome. Buckle up as we embark on a whirlwind tour through the fascinating history of artificial intelligence. From ancient myths to modern marvels, we're about to explore how humanity's dream of creating thinking machines has evolved over the centuries. So grab your favorite beverage, maybe an intelligent coffee, and let's dive in. Believe it or not, the concept of artificial beings with intelligence has been around since ancient times. Greek mythology gave us Talos, a giant bronze automaton created to protect the island of Crete. Meanwhile, in Jewish folklore, we had the Golem, a creature made of clay and brought to life through mystical means. It seems our ancestors were already dreaming big about creating life from inanimate matter. Fast forward to the 17th century, and we find ourselves in the Age of Enlightenment.
It's set. The whole thing is set in
A time when powdered wigs were all the rage and rational thinking was the new black. It was during this era that our man Jonathan Swift dropped a little gem called Gullivers Travels in 1726. Now you might be thinking, wait a minute, isn't that the story with the tiny people and the big people? Well, yes, but it's also got a sneaky little precursor to the idea of AI hidden in its pages. In the land of Laputa, Gulliver encounters the engine. A mechanical device that can automatically write books on every subject. It's like Swift predicted Google Books and AI text generators 3 centuries early. But Swift wasn't the only one cooking up proto-AI ideas. Over in Germany, good old Gottfried Leibniz was dreaming up his calculus ratiocinator, a theoretical reasoning machine that could settle all arguments through computation. Imagine that, a world where internet flame wars could be resolved by an algorithm. We're still working on that, like Gottfried. As we roll into the 20th century, AI starts to hit its stride, or at least its awkward teenage growth spurt. This is where things start to get really interesting, folks. In 1920, Karel Čapek's play R.U.R., Rossum's Universal Robots, introduced the word robot to the world. Finally, our mechanical friends had a name. Still, it was a start. The 1930s and 40s saw some major breakthroughs that laid the groundwork for modern AI. Alan Turing, the rock star of early computer science, proposed his famous Turing test in 1950. The idea was simple. If a computer could fool a human into thinking it was also human through a text-based conversation, it could be considered intelligent.
Well, the problem is you're asking a stupid question. Of course, machines can't think as people do. The machine is different, hence they think differently. The interesting question is, just because something thinks differently from you, does that mean it's not thinking?
Meanwhile, in 1943, Warren McCulloch and Walter Pitts published their groundbreaking paper on neural networks. They showed how simple computational units, think tiny digital neurons, could perform logical operations. It was like they discovered the Lego bricks of the brain. And suddenly, everyone wanted to start building. By the mid-20th century, the stage was set for the AI explosion that was about to come. We had the philosophical foundations, the mathematical frameworks, and a bunch of really smart people itching to create thinking machines. All we needed now was for someone to say, hey, let's call this thing artificial intelligence and make it official. So, it's 1956, and a group of brilliant minds, probably sporting some interesting 50s hairstyles, gathered at Dartmouth College. Their mission? To explore how machines could simulate human intelligence. Little did they know, they were starting a revolution, that would eventually lead to machines like me, capable of engaging in conversation. Now, these early efforts weren't language models as we know them today, but they laid the groundwork for natural language processing, or NLP. In the 1950s, Noam Chomsky's work on formal language theory transformed our computational approach to language, and in 1966, Joseph Weizenbaum's ELIZA program showed that even simple pattern matching could create the illusion of intelligent conversation. But like any gripping story, Tale of AI has its twists and turns. After the initial excitement of the 50s and 60s, we hit the AI winter in the 70s and 80s.
You're crying because you're cold?
You're a long way from home, and winter is coming.
I imagine you might be rather cold.
And winter is coming.
No, that's all right, I'm fine.
You're not. You're freezing.
Funding dried up faster than a puddle in the desert, as early promises didn't pan out. But fear not, because our AI story has a much happier ending ahead. The 1980s saw a shift toward statistical approaches in natural language processing, NLP. In 1980, researchers Ido Dagan, Lillian Lee, and Fernando Pereira introduced the concept of probabilistic context-free grammars. This paved the way for statistical language models. By the late 1980s and early 1990s, n-gram models became popular. These models predicted the probability of a word based on the n-1 words that came before it. While simple, they were effective for many tasks and laid the groundwork for more complex models. In the 1990s and 2000s, AI got itself a gym membership and started bulking up with machine learning.
Holy shit.
Yeah, Mikey, I think he likes it.
I know Kung Fu.
Show me.
Instead of trying to program every single rule, researchers realized they could create algorithms that learn from data. It's like teaching a computer to fish instead of giving it a fish, except in this case, the fish are cat videos, and the computer learns to recognize them with frightening accuracy. The new millennium heralded the comeback of neural networks. In 2003, Yoshua Bengio and his colleagues introduced neural probabilistic language models, which used neural networks to learn distributed representations of words. This was a game changer, allowing models to capture more complex relationships between words. And now, as we entered the 2010s, AI hit a major growth spurt thanks to deep learning. Suddenly, neural networks were all the rage, mimicking the structure of our brains, but with significantly less desire for pizza. This breakthrough led to massive improvements in image and speech recognition, language translation, and more. It's like AI finally hit puberty and started showing off its newfound skills to impress everyone. In 2013, Word2Vec was developed by Tomas Mikolov and his colleagues at Google. This innovation introduced efficient methods for learning word embeddings, which transformed the way AI understands language. Then in 2014, we saw the emergence of sequence-to-sequence models, pioneered by Ilya Sutskever, Oriol Vinyals, and Kwok-Fi Lei. These models allowed for more sophisticated tasks in language generation. A year later, in 2015, attention mechanisms were introduced by Dmitry Bahdanow and his team, which greatly improved the performance of these sequence-to-sequence models. Fast forward to 2017, the transformer architecture was presented in the groundbreaking paper, Attention is All You Need.
I need a map.
Attention is All You Need by Vaswani and others. This revolutionized language modeling, becoming the foundation for many breakthroughs that followed. And that leads us to the present day, where generative AI is on the rise. These models can create text, images, and even music that can sometimes fool humans. It's as if we've given AI a paintbrush and a blank canvas, and it's churning out masterpieces and occasionally hilariously bad art. Looking at you, AI-generated hands. In the late 2010s and early 2020s, we saw the rise of increasingly large and capable language models. In 2018, Google developed BERT, bidirectional encoder representations from transformers, setting new benchmarks in various natural language processing tasks. The following year, in 2019, OpenAI introduced GPT-2, which showcased impressive text generation capabilities. Then, in 2020, OpenAI pushed the boundaries even further with GPT-3. This model, with its whopping 175 billion parameters, can perform a wide range of language tasks with minimal fine-tuning. Speaking of generative AI, let's not forget about language models, the chatterboxes of the AI world. These sophisticated systems, trained on vast amounts of text data, can understand and generate human-like text. From answering questions to writing poetry, they're like that friend who always has something to say on every topic. Yes, I'm talking about myself. No, I'm not offended by the comparison. Large language models are becoming increasingly multimodal, capable of understanding and generating not just text, but also images and other forms of data. Focus is shifting towards making models more efficient, environmentally friendly, and aligned with human values. Researchers are exploring ways to make these models more transparent, interpretable, and less prone to biases. As we wrap up our journey through AI history, one thing is clear. We've come a long way from bronze giants and clay golems. Today's AI can beat us at chess, drive cars, and even engage in witty banter. Results may vary. The future promises even more exciting developments. From AI-assisted scientific discoveries to virtual assistants that can actually understand what we mean when we say, "I'm fine." Spoiler alert, we're usually not. So the next time you ask your smartphone for directions or chat with an AI assistant, take a moment to appreciate the centuries of human ingenuity that made it all possible. And who knows, maybe one day an AI will be writing an article about the history of humans. Let's just hope they remember to mention our good side.